Video number 2 introduces the QVJul's performance analytics and yield management items, including the real-time interface and mode targeting and some comparative and historical analysis options. To begin with, the real-time interface, as you saw, was shown on the video number 1, provides the operator a variety of options in terms of how to view what he is doing, what the process is doing compared to various targets. In this case, what you're looking at on the side where the blue is are the individual products for this particular plant, half-inch down to screening. The blue is the indicator of the actual real-time scale output. The gray behind it, or light blue depending on your color perception, is the target for the ton per hour target for that particular mode. The modes are selected in this interface manually, but they can be selected by the computer from the optimization. The mode is shown up here, all 1.5 inch recrushed, all 1.25 inch recrushed, the rest of it going out to product. Changing the mode is done by selecting the option and picking which mode you want to use for your current target. And in this case, we'll take mode number 12. And you see it substitutes and adjusts the targets. The scale data on the left is for the primary, which includes the surge input and the dense graded aggregate material, the base product that's scalped out. The relationship between the surge in and the screen plant in or surge out, obviously throughout the course of the day, is something that would be monitored. You can see here the graphic over real time, showing the period from 7 o'clock to 10 o'clock, and indicating the screenings are produced at 200 tons an hour or 150 tons an hour for the 3/8, which is the driving product, and the other driving product is the quarter. This is the in-feed. The surge in is here, and the primary is here. But the graphics can be selected by the user to show what is of significance from an individual's perspective. You can see there are some statistics. We have target yield based on the mode. Target ton per hour, and here's the real-time ton per hour and the current tonnage. The day totals are here, and we have a predictive end-of-day calculation. We have a target, yes, but we have an end-of-day calculation for each of the individual products based on the performance up to the given point in the day that we're looking at. We also have the same sort of predictive end-of-day results for comparison on value, dollar per ton, variable cost per ton, and total cost for the day against the targets. This particular interface tracks the scheduled hours based on a specified belt scale. It indicates that the plant is running and has material in it, and it shows the percent runtime. Uses a standard variable cost per scheduled hour to calculate the cost for each segment of the process, assigning $3,000 per scheduled hour to the crushing and screening plant and $1,500 for the primary and the pit. The hour schedule is set up here. The remaining hours and the actual operating hours are also calculated. And the key takeaway from this is the ability to select a proper mode, something that means something, realistic, based on the scale data. Also have the capability to capture mode, and basically if I snap this, I can create a new mode and capture it just as it shows here, and give it whatever name I want to give it, and can be used as another point of comparison. The modes list includes the current year-to-date data from the scale system, the previous 30 days, 60 days, and 10 days, as well as some experimental modes that I put in here. The ultimate purpose of the belt scale system is to create modes and production rates that represent realistic limits and capabilities of the process, and then can be used as targets to improve the performance of the plant in terms of operating cost by reducing the byproduct, in this case the screenings, and increasing the key products, which is really the 5/8, 3/8, and 1/4 inch of this particular plant. You'll see the chart on the left represents the end of day results over a period of time. In this case, showing just 2014. We'll add the 2015 data into it. Automatically reconfigures the table that the chart is based on to give us whatever period of data that we choose to look at. The data can be turned on and turned off to clarify the results as appropriate. Here we've got all these products on. Just take the 3 key products, and the system actually allows you to make adjustments to the chart so you can do your basic evaluation of the results graphically. At the same time, you have the results for that period of time that we're looking at. It will be May through October of 2014 and 2015. You can see if we turn 2015 off, the date changes. The chart has some extra utilities. For example, if you don't like the color of a selected item, you can turn it from one color to another with just a little bit of clicking here and there. It's kind of intended to make things easy to visualize and easy to use. The scale can be adjusted so we can look at any area of the plant that is appropriate for the analysis we're doing, and have a scale that depicts what we want to see. In this case, I'll take a look at the primary. And you see the primary, and we see that it's blue. We don't want to be confused with colors. We can just right click. The data here is trended, as you can see. It's a 10-day count. I can take it down to a 2-day count to see a little bit more what variability exists from day to day. And you know, there's a few other utilities, but the important thing is you can look at a period of time, whether it be down to a month, and see what the yield was, so you can begin comparing the data that you have on the scale analytics side to historical data. So here's another on the right. Take that down to a date, 1 day at a time sort of thing. This happens to be August 5th, 2014, and it's calendar selectable, so you can click on a date, September the 10th. Arbitrary days. Looks like they're recrushing the 5/8. The yield of the key product went from 150 tons an hour, what we're looking at over here, to over 200 tons an hour. Unfortunately, the screenings did also, so you got a bit of opportunity to look at that. This is intended for benchmarking purposes, so you see the yield here. With regard to comparative issues, we have both inventory and production tables, and you see there is nothing in the production. You see there's nothing in the production side. However, if I scoot up here and tell the
Solver is using current constraints to calculate maximum potential revenue. Solver calculations are complete. All constraints are satisfied.
You can see that there are no constraints placed here, and production side, and no constraints placed here on the inventory side. We'll get into that in the next video. But you will see over here that we have an option for discounting the scale data. You can see on the far left here we have a factor to take into consideration potential loss factors for inventory stockpiles or waste or wash loss. For example, if we went to the 5/8 and said we're going to suggest that 10% of that product is not going to be recoverable, you can see the adjustment down here, 23.4 down to 23.41. To make that 0, it goes back to 23.89. So you can have a reported production number, not just here, but in your daily report, or you can have the actual scaled number to look at. Both tables have the ability to expand and show the comparison. In this case, it's referring to actuals that I'm going to use for example in the next video. The actual versus the ending inventory versus the optimization ending inventory, which we can control with some constraints here. And you see that we wouldn't really allow this to end with a 0 inventory. We would put constraints in for a minimum ending inventory. And the same thing could apply over here with regard to the comparison of production actual versus or scale results versus the optimization. And the constraints could also be based on the intention to limit the production of certain products. Well, there's actually more than that in terms of capabilities within the analytics, but the essence of it is what you saw. There's a lot more behind what I showed you, and some of the calculations that occur dynamically are embedded in the reporting that I showed in the previous video. Some of them are unique to each site, correlation and regression analysis that with the tools that are here and the automated element in terms of processing the data and presenting the data in a intuitive sort of form. It gives you capabilities for insight into your operating performance limits and capabilities that just don't exist anywhere else.